Back in our demonstration, we're still on the Instance Configuration tab. We've selected that we're going to install SQL Server as a default instance, and we see that the instance ID and SQL Server directory are all at their defaults. We can change the instance root directory if we want, but there's really no need to, because that directory is only where the binaries are going to go. It's not where the actual databases are going to go. Clicking Next takes us to the next page of the wizard. This is the disk space requirements. So we can see here how much space is required and how much space is available on all the various drives we've selected so far. We're only using the C drive, so we only need a small amount of space there. You can actually see SQL Server is breaking it down per folder as to how much space is needed. We click Next and we're taken to the server configuration screen. On this screen, we can set the service accounts that are going to run the SQL Server database engine, the startup type for those various services, as well as the collation for the instance. Each instance has its own collation. One of the reasons you may have multiple instances on a single server is because you have databases that need multiple collations and don't necessarily support being on a server that has a different collation than the database is configured for. While this in reality is not that big a deal anymore, thanks to partially contained databases, this does require the application vendor's buy-off and support before you can mix collations on a single server. Once we've set our collation and service accounts correctly, we can go ahead and click Next. This takes us to the database engine configuration page. On this page, we set the authentication mode as either Windows authentication or mixed mode, specify all the various administrators that we need for the server, or that at least are going to have access to the server at the very beginning of the server coming online. We can change the administrators list later. For right now, we're just going to click Add Current User to give myself administrative rights. On the Data Directories tab, we can see where the databases are all going to be created. The data root directory can be modified as necessary to modify the system databases directory. The system database directory cannot be manually modified. If you need to move the system databases into a different folder structure, you'll need to do that manually and then change the registry keys that point to those settings. User databases, user database logs, tempdb logs, and backup directories can all be specified. The last tab is to enable FileStream or leave FileStream disabled for this particular instance. If we need FileStream enabled, turn it on here. If it's not turned on here, you can turn it on later through the SQL Server Configuration Manager and then through properties of the database instance. Clicking Next takes us to the error reporting page. Here we can tell SQL Server to send any dump messages and any debug messages back to Microsoft automatically. There is a slight risk of private data being sent to Microsoft if you turn this feature on, although it is not very likely because it's only going to be sending T-SQL commands that caused the dump and the actual debug of the dump. There shouldn't be any actual user data being sent, and Microsoft would never upload an actual database backup to themselves without you explicitly doing it. Clicking Next takes us to the Instance Configuration Rules page. This is the last rule check that we're going to run. We're going to want to make sure that there are no warnings or errors, which we've done so here. Verify that we're not using a FAT32 file system, we're not on a clustered or clustered prepared instance, we're not running a cross-language installation, and we're using the same architecture for the installer as we're running for the operating system. We go ahead and click Next. We verify all the things that we're going to do, and we're also given the path to the INI file, which holds all these settings. We could use this INI file to automate this installation on other machines should we need to. When we click the Install button, SQL Server is actually beginning the installation by putting the actual bits down on the disk, creating the system databases, master, model, MSDB, tempdb, and bringing the instance online. Once the installation is complete, then we can actually click Finish and then connect to the instance and begin our actual configuration of the instance with any specifics that we need to configure. Typically installing an instance, even on an incredibly fast machine, takes 15 minutes to 20 minutes or so. We're not going to wait through the entire process of actually putting down all the bits because it does take a very long time and there's no additional options to configure as far as doing the actual installation. Would we need to install another instance of SQL Server on this machine, we would simply wait for this installation to complete and taken back to the SQL Server Installation Center, which you can see in the background. We'd simply click on the same link we clicked on before which would give us the opportunity to install another instance on the machine. In summary, the only changes to the installation process are really the instance name, the instance ID, and the path to the installed files. The instances really do not have any knowledge of each other. They only share very, very minimal files, like drivers and things along those lines. Although they can be patched at different times, there's this concept of shared objects, like Management Studio, which you only install once no matter how many instances you have. Don't forget that each instance is totally independent from each other. So there's no communication between them, which is why you have to run through the installation process one at a time for each instance that you want to install on the server.